wake up. So this was another, that was the first training here in January 2013 that I gave with the Dream. Everybody's like, what's this doing? Can't believe it's so simple. See, there was at the beach house, which unfortunately has closed. I like that place so much. It was right in that big green round, close to the UP sign. And I must say, my students back then, they really got pleasure out of working with my software, I think. Because I looked at their notes and I said, wow. But maybe it was because, you know, we had one day a pizza event, and then the other day we had a t-shirt contest. And then, yeah, I'm really very happy. And I also got a suggestion for a better t-shirt. I think it was Joyda who came up with that design. All right. Good. So let's do some LiDAR and forestry. Do you still have a good data set for this? Is the one from Poland, because I didn't really see in the data we looked at from the Dream, I didn't see a lot of forests in there. And magnifier. Run new task. Well, here we have so many clouds, and here we didn't have a whole lot of vegetation. Now it's final. Not so much vegetation. Not so much vegetation. Oh. Well, actually, why don't I just use my DSM to look at that as an interesting area. If I can't find an interesting area with a lot of data, then we're going to use the Polish data set. Okay, maybe we do the lowest ones. The lowest ones that maybe have a little bit. So let's see, the lowest ones are 20. Looking at the nice thing is you can just look at the names of the files, and they are the lower left coordinate. This is the lower left coordinate, so I know the one ending in 200, those must be the two lows. Yeah. Yeah, actually maybe. How can I quickly find out the height of the forest? So I see if it's worthwhile to compute something here. Or I can zoom in and look at them a little bit like this. I can say G, get the ground points, triangulate. V, get the vegetation points. And now, one very easy way to do it, I can hang on the drop lines, maybe 10-meter drop lines. not super high. Let me get rid of the drop lines again. I can select render only the ground points and the vegetation points. Okay. So I take one of the top points here and make the points bigger, so I can take easily select them. One of the top points as the eye. Now I have the height here, and I go now around. The ground is pretty flat, so I can take any one of these ground points and say eye again. So 91 and 67. So how high is my highest tree? 167. Oh, it's 24 meters. So they're around 20 meters. Yeah. So let's take that data instead of the published data. But maybe instead of rendering the whole thing, because there's not a lot of forest, we will only render we will only work with these two tiles. The one ending in 2000, because those are the lowest, and that's where some forest was. Just to make the processing a little quicker. Maybe we use this as an exercise. Let's cut out some data. Sometimes you want to cut out some data because you want to do some experiments with it. And for this, I would like you to start the tool LAStools. I thought before LAStools, that's actually one of the free open source tools. It is the Swiss Army knife, I called it before. And I hope you still all have your sample data, so I'm now going to Agno. 1 kilometer, and I'm going to the final tiles, and I'm loading them all in. And now I know I want something sort of from the bottom here. And before I cut something out, I can just pick. I can pick some of that data. Okay, let's pick this much, for example. Remember, you can pick. You click it once, and then you can make a rectangle. And if you now say view, you can view the area you have selected. And that rectangle you picked, that's basically corresponds to this one here. So, oh yeah, that looks good. I could maybe go a little bit higher, but that's sufficient for what I want to demonstrate. Just a little bit of forest. One warning here, this is not really a forest, this is a city. I just wanted to work on it. So the city, the houses will contribute to our forestry metrics. So that will, later on we're also going to do the forestry metrics on that data set. The houses will be counted like forest. You would have to exclude them first. We classified some of them, but the classification is not reliable. So to do it urban, because that's like urban forestry, is a bit more difficult, because you need usually higher density data to properly distinguish the houses from the vegetation in the first place. Or you need to fiddle around with the classification, so you get. Or you need to get, to go to OpenStreetMap and get good building footprints and use them to clip out the LiDAR points that are houses. Because OpenStreetMap has pretty good building footprints for the Philippines. There's a huge movement. One of the local heroes is Manning Sambale. I hope he's coming for lunch. I was trying to meet him for quite some time and to ask to come. And I think he. Okay, I hope I won't regret this working with this data as forestry data, but you know, it's more fun in the Philippines. And I should have asked to get better data. So we could just use the lower two tiles, but that would be too easy and I would miss an opportunity for an exercise of clipping. So I want to clip down this area. Maybe I want to make these values a little nicer. I mean, I want to have everything in X and everything in, I want the entire data in this direction, but here I want a nice clean cut. And I don't want it exactly in the tile boundary, otherwise the exercise would be pointless. So I can edit the upper right Y here. And you see this number is kind of crooked, like 2,894. So I can just write a nice round number here, maybe 900. And if you press return, and you look at what the rectangle is doing, it moves just a little bit to be on a nice round number. And now I can actually merge this clip area into one file, and then I'm just working on one file for this little forest evaluation in what is not only forest here. So I say merge file into one, and I give it an output name, and I call it fake. I call it FF, like fake forest, because it's not really a forest. It's a lot of houses in between. Fake forest.last, nice and short. And I select an output directory. Maybe just right here, next to all these. And that's it. So what this will do now, it will basically clip out this area and create a new LAZ file that is merging these two tiles into one. And this is how it looks like. Last to last, list of file. And for those who came late, these are the tiles final from Agno. And I'm cutting out now the bottom piece of it. What's in the list? Oh, that's strange. In the list there's only two files. Why is that? Well, because it's a smart clip operation. It realized the red rectangle didn't overlap all of the tiles. It only overlapped the bounding box of the lowest two. So I still have to clip within those two, but I don't need to clip all the others because they definitely will not be part of that. And then here I have my clipping area, and it's going to be all the points, and the only real clip is this one. You know, I'm not going to take any points that's above this Y value, and that's the one I manually edited. You see, I could have also manually edited here. Also, I wouldn't get the visual check of the changing red bounding box. So I put the output here and ff.last. And I say start, and that should be rather quick. Alright, now you see how you can clip out a piece of data. Very easy. one other thing you can do if you want to guarantee to pick a square, something square, you can just enable square tile. You can say I want to have a 100 meter tile, and then you just click anywhere here. Ooh, click anywhere here, and you always get a 100 meter tile. Pick 100 meter tile. Sometimes you just want to have a nice clean area, and then you can go in here and edit this to be a nice round number, 850. And then it falls on some nice round numbers. That's just another option. Okay, somewhere I have my ff.lux file now. It should be in the Agno directory. Oh, in the Agno 1 kilometer directory. So let's stop now. Yeah, maybe I should create another directory here. Otherwise it's going to get too cluttery. So I create myself a new directory. I just kind of call this forest. So we can do some forest. And I will copy that file into there. Control X. Control V. And I can just double click it. And then you see these two tiles are now in one. And they're still in the original order. If you press P, you can play it again. The order that the points are in the file. So just appended them. And the point here at the very top, they should have a y coordinate of just below 900. So if I zoom in on these points here, and I pick them and I check their coordinates, $899. So very close to 900. Everything above 900 was cut off. Okay, so we have now a cutout file. What we do now is called normalizing. We will now normalize the LiDAR so that the ground points become 0 and all the other points have an elevation that is basically their height above the ground. And the tool for doing this is LAStools. We used it yesterday already for cutting off the clouds, but you can also use it to normalize LiDAR data. So I look for LAStools with this. I'm looking for my sample data. I know 1 kilometer, and I created a new directory called forest. It is.